Remember, treat these like you would any other algebra equation. Because the whole idea of these algebra equations is you guys, as you guys get further along, remember we talked about this. Equations are something you've been doing since first grade. 3 plus box equals 7. You've been doing this stuff. And each year they got progressively more difficult. Same thing happens as you get into algebra, algebra 2, geometry, pre-calc. We still deal with the same stuff. We're still solving for x. We're still trying to find it. Okay? So what we work with now is we're going to, in order for us to solve upper level equations then, we have to know about specific identities and properties of trig functions. Some of which you already know. For example, if I talk about secant of x is the inverse of which trig function? Cosine. 1 over cosine equals secant. Which means cosine equals 1 over secant. Okay? What's the inverse function of sine? Cosecant. So cosecant is 1 over sine. Which means sine is 1 over cosecant. What's the inverse of tangent? So cotangent is 1 over tangent, which means tangent is, there you go. You know, we know about the reciprocal properties. Yeah, we knew all of this. Yes, sir.
Wait, so cosecant is the opposite of sine?
Yes, sir.
I've been doing that wrong this entire time.
Well, hopefully now you'll change.
Yeah.
Speaking of tangent and cotangent, tangent is what over what in terms of sines and cosines? Y over x, otherwise known as? Sine over cosine. Very good. Therefore, if cotangent is, or sorry, if sine is, excuse me, if tangent, I'll get it right eventually, if tangent is sine over cosine, what's cotangent then? That's it. Cosine over sine. Okay. All right, let's try something even fancier. What do you want?
Why is it that secant is the inverse of cosecant? Like, why do they name it that way?
I don't know. I wasn't there.
Well, you should have.
Yeah. Yeah.
Well, I'm sure it has something to do with like the Greek. Let me show you something cool. Unit circle? You okay with that?
Yeah. Do we have
Okay.
to draw this?
No, you don't have to draw this. Bless you. What's the radius of the unit circle? 1. Okay. If I place a theta value at the origin, this is my opposite, this is my adjacent. Are you okay with that?
Yeah.
The distance of my opposite value from here to here was our what value? The y value, otherwise known as sine. We went cosine, sine. So this distance here was our sine value, whereas this distance here was our cosine value. Now, what Watch what happens after I get rid of all this stupid stuff. That's a right triangle, isn't it?
Yeah.
What's the Pythagorean theorem?
A squared plus b squared equals c squared.
Therefore, sine squared plus cosine squared equals
Tan squared.
1. Yep. Sine squared of x plus cosine squared of x is going to equal 1. It's a Pythagorean identity. Okay? We have Pythagorean identities. Yes, sir?
It's not squaring x, it's just sine squared.
Yeah, and this is, I want to show you what happens here. When you take, if you have sine of x times sine of x, the way that it's written is always sine squared of x. That's the way that it's written. Okay? You don't have to square the x value or anything like that. That's just how they write it. So the idea here is we get this Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. It's a pretty important thing to remember because place of theta, your opposite is your sine, your adjacent is your cosine. There's your radius, it's going to be 1 in the unit circle. All right? Now, what that means is that you could get sine squared by itself. How? Very good. Which means I can manipulate this and say sine squared of x equals 1 minus the cosine squared. And I can do the exact same thing by getting cosine squared by itself. Okay.
Isn't this mean like sine plus cosine equals 1?
No.
Because if you take the square root.
Ah! That's killing puppies. Can't do that.
Oh,
What does cosine squared have to equal then?
Negative, I mean, 1 minus sine.
1 minus sine squared. Good. So this is kind of a little Pythagorean trigonometric identity family. The generic is the sine squared plus cosine squared is 1. And then you can manipulate the equation to get the other ones by themselves. Yes, sir?
1 is still the scalar, correct?
Yes, sir. Now there's two other ones that you use as well. The two other that we work with are going to be 1 plus tangent squared of x is secant squared, and 1 plus cotangent squared is cosecant squared. And obviously you can manipulate the equations to get cotangent by itself, you can get tangent by itself by subtracting 1.
Oh, it's the bad day.
Like I said, what we're going to do over the course of probably the next 3 or 4 days is spend the time in 14.3 to work through these properties in problems that are called simplify or verify trigonometric identities. Whatever. I got these. Now, these sheets have all the basics on them. It doesn't have the ones where we wrote out. Oh, Carter's hogging them all.
Either one of us will like take it.
Society.
Front row people are just bad. Thank you, sir. Like I said, these don't have everything on there. They've got the basics. If I read this, it says cosecant's 1 over sine. But what else did I say sine was equal to? 1 over cosine. So as I'm working through all of my stuff over the course of the next 3-4 days, I would probably write down some of the extra properties on here. Write down the inverse ones. Write down the 3 different ways I can solve and get sine by itself, or sine squared by itself, get cosine squared by itself, get tangent squared by itself, and so on. Yes, ma'am? What's happening here is that we're going to be doing a lot of substitution. We're going to be doing a lot of let something equal this and you substitute and re-simplify. You're going to see problems that look like.
Is this going to be scary?
Does it get scary?
Is this going to be scary?
It's kind of scary.
I don't know.
You can see it better.
that is
God.
Oh,
God.
Oh, no.
That is.
Oh, he's gonna put
it in a drink.
This, the sine of b divided by the tangent of b equals
Cosby.
the cosine of b.
Eric, watch out, he's gonna put it in a drink.
I know it's taken the luster of the problem has kind of gone away since Bill Cosby's been possibly bad. Yeah. Anyway, so we just leave it at that. Anyway, here's what happens.
You didn't know that?
Yeah, there's a lot of, yeah.
That's why I was asking.
I only used it because if I use the one with the tangerine, nobody understands it, so the Cosby stayed.
How would you
I'll show it.
tangent?
I'll show you.
The tangent of green?
I'll show you. There's not a lot of math puns out there, and I tried my best to find some. So here's what happens. Guys, here's what happens. This is an example of something called verify. Verify and simplify are two different things. Verify versus simplify. Verify has an equal sign. It tells you the answer. Simplify just means simplify. Try to get it as to the most simplistic form as you possibly can. Think of this as a monomial. And you'd have to simplify that. Remember doing that? Exactly. You don't know when you're done, but when you work through it, you try to get it to the most simplest, this most prime factor, if you want to think of it that way. So we're going to do two different types of problems. If you see an equal sign, that means you know what your answer's got to be in the end. If you don't, you just have to work it through till you think that you are done. Exactly. That's, yeah, usually what happens. Now, I'm not going to lie. These are probably one of the more tricky things that we do during second semester. I'm just bringing the problem over to start to show what's happening here. So as we go back to the verify problem of the sine of b, tangent of b, two things I want you to notice. First, it's an equal sign, tells you your answer. Second, notice that the value for all of them has a b in it. That just means it's your angle. There's some x, there's some theta, there's something there. All of these problems, that unknown variable for the angle part, they always have to be the same. If they're not, you can't do the problem. So a lot of times, what I wind up doing is just this. I usually don't write the variable. It's bad form, but it's cleaner. It's only going to work because all the variables are going to be the same. You're not going to see any problem that doesn't have that has different variables, okay? So if I just say sine over tangent, I want to show that it equals cosine. That just means that it has some theta, it has some x, some b. That's always the same. Does that make sense? So there's a couple things that wind up doing. And this is kind of like a proof in algebra. Okay? So you have to remember what certain properties mean in math. When you're dividing, sine divided by tangent, doesn't that also mean you're multiplying by 1 over something? If I take 3 divided by 2, isn't it the same as saying 3 times 1/2? Yes. So this is the same thing as writing this. Sine over 1 times 1 over tangent. I split apart and pulled apart the fraction. All right? Guys, come on. What does 1 over tangent mean? Cotangent. Very good. What is cotangent in terms of sines and cosines? Very good. What simplifies?
Cosine.
Sine.
Because what's sine divided by sine?
Cosine.
1.
And you simplified it. You verified that it equals.
We're just going around in circles, Leo. This is math. Going around in circles.
It's useless, man. Thank you, Mariah.
You're welcome.
Great.
Again, guys, what we're doing here is we're learning about the properties so that you can solve more complex equations. As you get into these, you have to know how the properties work. Simplify and verify. You're rewriting and substituting in. I had sine and a tangent to start with, and I wanted to show that it equaled a cosine. A lot of times with the tricks with these problems, try to rewrite things in terms of sines and cosines, because with fractions, things can simplify off. Simplify diagonal.
I
Okay?
feel like we can do like proofs with this stuff. That's not what
This is a proof.
Okay.
This is it's a trigonometric proof, not like a 2-column version of it. Yes, ma'am.
Would we have to write out that whole thing for a problem?
Yeah. Oh yeah. Simplify. Cotangent times secant. Again, just write it like this. Cotangent, secant. You want to simplify that. A couple of tricks that I would start to remember. First of all, anytime you're given stuff that are all written out in terms of inverse properties, rewrite them in terms of the reciprocal. Cotangent is the reciprocal of what? Secant's the reciprocal of what? Okay. Also, in this case, cotangent. What is that in terms of sine and cosine? Cosine over sine. So what I can do is rewrite cotangent as cosine over sine. And what's secant? 1 over cosine. What simplifies? Is that sine value wearing a life preserver?
No.
So is it going to float up?
No.
No. Your answer is 1 over sine.
Can I say it's just? I mean.
Which means the most, it is, and that's the point I was getting to. Which means there's one more step that I can go to make it even simpler. That's the same thing as saying cosecant.
I love math. What?
1 over sine is cosecant. It's the inverse. It's the reciprocal property. Yeah, Bill, what you got?
Actually, no.
Good conversation. All right, let's try another one. As you start to see ones that have squares in them, if there's a plus sign, if there's a minus sign along with the square, automatically look to see if it's one of the Pythagorean identities. Check to see on the list, is there something on there that says 1 plus cotangent squared?
Yeah.
Yes, I said yes.
1 plus cotangent squared is what? Cosecant squared. So I can rewrite this as sine times cosecant, squared. No. Cosecant squared is a reciprocal property, isn't it? So it becomes 1 over sine squared. Oh, sorry. I skipped that. What drops? How many of them?
1.
Just 1. And again, is this sign in the denominator wearing a flotation device?
No.
No. So what's your answer?
1. 1 over sine.
Otherwise known as? So does every one of these always simplify out to cosecant?
Yes.
Yes.
No.
No.
Wait, I don't know.
Yeah, Bill.
Like on the last one, how do you know which one you're supposed to be trying to get rid of? Like why would you try to get rid of something?
And this one here?
No, the one. Why would you try to get rid of
Oh, because I have more cosines to work with. It starts to become more evident as you start. See how I have cosine over sine, 1 over cosine?
Yeah, but why would you put sine over 1?
I don't have that. It's cosine over sine. I don't have anything here in terms of sines. I have cotangent is cosine over sine. Secant 1 over cosine. The only sign I have there is part of the cotangent. It's in the denominator. Absolutely, please, it's fine. Guys, Brian's just asking, can you disregard these x values? Please do. They just get in the way. Your x is always getting in the way. Mr. Pope, what do you got?
How do you get to cosecant squared?
How to get the cosecant squared? This one is a Pythagorean identity. On your sheet, 1 plus cotangent squared is cosecant squared. And yeah, you're going to have to be referring back and forth to these things all the time. You will have to know them. To be honest with you, you already know the reciprocal properties. You know tangent is sine over cosine. You know cotangent is cosine over sine. It's really easy to remember sine squared plus cosine squared. It's the other two that take a little bit of time to remember. Okay. Just like when you had to learn first angle of the unit circle was 30 degrees, everything else fell into place. Here, you probably only have to remember 2 of them. The 1 plus cotangent squared and the 1 plus tangent squared. Okay. Verify. Again, what's the difference between verify and simplify? You have an equal sign. So we need to verify that cosine times secant equals 1.
Oh, that's easy.
So let's rewrite, isn't secant the reciprocal of cosine? So you show that. Cosine over 1 times 1 over cosine. What happens?
Everything
Whoa.
And then you smile.
So that's how you fail.
Just nice.
What do you think I'm going to tell you to do on something like this?
Look at the inverse.
Look at the inverse. Rewrite everything in terms of. Say it. You're about to. Reciprocal. Write everything in terms of sines and cosines if you can.
Yeah.
If you can, try to break things down into terms of sines and cosines, because as you rewrite your fractions, you'll see how things start to simplify themselves out. So you have tangent, cosecant, cosine. And I want to verify that that simplifies to equal 1. So rewrite it. What's tangent? So you get sine over cosine. Cosecant is
1 over sine.
argon.
Oh, you grew.
And what's the next one?
Cosine over sine.
And now the fun part. No, 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 no.
Well, that's fine.
Sorry. Forgot the most important thing of the whole problem, the smiley face.
Why isn't it cosine?
Alrighty. Sometimes you have to split between division to show subtraction. Yep. Since there's an equal sign, we have to verify. So you have cotangent squared over cosecant, and you want this to equal cosecant minus sine. Now there's a couple of tricks that are happening here. First of all, notice how you start with a monomial and you wind up with a binomial. A binomial with subtraction between the two. In order to have subtraction coming from a fraction, don't you have to show that you have a common denominator?
Yes.
Yeah. So take a look at the numerator here versus the denominator. Notice how the numerator has a higher degree. Since the numerator has a higher degree, that means that it has a possible way of splitting it apart if you had to add things. So think about it. Cotangent squared. What can you rewrite cotangent squared as in terms of one of your Pythagoreans? Very good. So I can rewrite the numerator here as cosecant squared minus 1, and that's all over cosecant. Ah.
Okay, I got it.
You see where this is going now?
Yeah, I got it.
Now I have two terms in my numerator all over one part in the denominator, which means I can split them apart. So I can get cosecant squared over cosecant minus 1 over cosecant. This is the same exact idea as doing this. It means the same exact same thing. Yeah, I might have said that twice. Maybe. It's the same stuff. It's just got trig involved. Okay? So now look at, you have cosecant squared over cosecant. What do you get? Cosecant. And what's 1 over cosecant? What do you got? Ah. Yes, ma'am.
And on the test, if it's not in the proper form, when you put the X's and stuff, you read it as that.
Yeah. Because even if I try to remind myself to put the X in there, I always forget anyway. Yes, sir.
Okay, so can't you just like, what'd you do with the cosine or cosecant minus sine? Can't you just do like make it the same thing for both equal signs and it'll be good, or do you have to do for like answering this on a test? Do you have to
Excuse me.
you have to like show that it goes back?
Bless you.
Because I feel like I'm gonna forget to like go like simplify it and then go back. If that makes sense.
Usually what happens is that you're going to get, you want to take, in Algebra 2 we usually set you guys up to go from left to right. Make the left look like the right. Because the more complex stuff is usually on the left, and it's easier to work the more complex first because there's more things you can do with it as opposed to the stuff on the right. You can do the stuff on the right by getting common denominators and multiplying stuff back and forth. You can get there, but we'll worry about that kind of craziness later. Yes, ma'am?
Why would you turn cotangent squared into cosecant squared?
One of the Pythagorean identities is 1 plus cotangent squared is cosecant squared. So if I move the 1, there's your cotangent using substitution. You're going to see a ton of that, especially with squared terms. Okay? Verify this. Make the left look like the right. I have 2 parts in the denominator, so I can't split apart my fractions. But what did you do when you did this? You cried. Okay. After you cried, what did you do?
Multiply
By what?
4 plus 5.
4 plus I. You multiplied by a conjugate, didn't you? You created a perfect square, a difference of squares in the denominator by multiplying by some factor of 1. What did you do when you had this?
Also cried.
After you got done crying, what did you multiply it by?
Minus 3.
You multiply top bottom by the conjugate again. To create a difference of squares in the denominator. So what do you think I'm going to do to the after we're done crying? Oops.
1.
After we're done crying, what am I going to multiply the fraction on the left by? Let's go. I'm going to multiply by its conjugate again. Some factor of 1. Because if I FOIL out that denominator, I get 1 minus cosine plus cosine minus cosine squared. So I get 1 minus cosine squared in the denominator. I create a difference of squares. Multiplying by conjugates, you will see quite often with these problems, to allow you to create a perfect square trinomial in the denominator. Excuse me. Numerator doesn't really do me much except for the fact I get this, sine times 1 plus cosine. Now look at your denominator. You have a squared cosine with a 1. Can I rewrite that as something else? Very good. 1 minus cosine squared is one of the family parts of the Pythagorean identity of sine squared cosine squared. So if I subtract the cosine over, I get sine squared equals 1 minus cosine squared. So you get sine 1 plus cosine over sine squared. And what happens? How many? Just one of them. And you wind up with 1 plus cosine over sine. Otherwise known as cosecant plus cotangent. This one asks us to verify to this point. You're done. You verified. Okay. Oh no. Yes, sir.
I messed up.
Okay. There's a lot of little tricks that happen as you play through some of these. They are not very clean to start out with. Some of them are going to be pretty gnarly and you're not going to like me very much, and I'll get over it. Can I go another one?
Yes.
I don't want to do that, one's too easy.
I'm stoked.
Solving complex problems.
You don't want to do that.
No, wait, Eric.
Well, when you look like you, that kind of happens.
That was beautiful.
And no, I'm not buying a baseball card. Not buying one of those either.
You want to buy some?
No, I'm not buying that either.
laundry detergent?
Jeez. You guys are like Walmart.
I don't know that you can buy.
I can hook you up with some caramel cream.
Why
I'll
would
sell you a
Walmart
clip of my hair.
high school?
Secant squared minus tangent squared. Simplify it. What do you get?
1.
1. Go to the next problem.
What?
I mean, what the hell?
What?
You got me. I'll say that.
You got me. I start to cry.
Isn't that the identity?
Wow, it's right here in my face.
Oh!
How am I supposed to know?
Well, you need to know those. Have I mentioned that yet?
I'm too busy crying.
Well, once you're done crying, then you need to know those identities.
Dry the tears out of your eyes.
Our homework is a worksheet.
The problems are on the worksheet. You're going to need a separate sheet of paper to simplify.
Here it comes. Here it comes.
Do you need it now?
Mr. Murphy, where did the 1 come from?
Pythagorean identity. 1 plus tangent squared is secant squared. So on this one here,
If you look at the.
this is an old worksheet that we've had for a long, long time ago. Start where it says written exercise. I want you to do 4 through 44 every 4.
So.
Yeah.
On which side?
So can you count by 4s?
Probably.
I hope you can.
So I feel like.
Now, if you flip over, you'll notice one of them is crossed off, number 28. You don't have to worry about that one. I'll let that one go. And we haven't gotten to the point where we've done a lot of the common denominator ones, but we'll get going here. What I want you guys to try and go through here is the first half of these, getting, let's see, 4, 8, 12, 16, those should all be pretty easy. By the time you flip over to 20, that one's okay. 24 might be a little, let's see what you can get. 32 is a verified, should be pretty easy. 36. I will give you a hint. On 36, rewrite as sines and cosine and get a common denominator.
For 36.
Rewrite as sine and cosines and get a common denominator. One of the tricks is whenever you see something where you've got like a secant squared plus cosecant squared, and then all of a sudden it equals secant cosecant when they're multiplied, that meant that this combination had to get a common denominator to make it work. There had to have been some sort of a common denominator thrown in there to make it work like that. Yes, ma'am?
Can you tell us the rest of the identities?
We did them all.
And they're all in the
Yeah. Yeah, I don't know if we're gonna get to do any of the like the sine of negative x is negative sine. I don't know if we'll do the cofunction ones or the pi over 2 minus theta. I don't think we're gonna do any of those. So that's usually be safe. We gotta save something for you guys to learn to freak out. All right.
Hi guys.